only one wire. The standing wave is a best represented like this. This is a representation of stand. So who will determine how many loops? That we'll see later on. If the wire vibrates at higher frequency, instead of seeing one wire, you see loop. I think this is a very simple. You take a rope, same 5-meter rope, plastic one I said, no, tie it to the grill of a window or something, or a door, lock or door. Start making it to vibrate. You move your hand up and down. Then as you move your arm up and down, incident wave is set up. At other end, the reflected will come. Both will undergo superposition. You see the shape of the rope like this. Are you getting the idea? This one and this will call as an antinode. Oh, sorry, these are nodes. This is a representation of diagrammatic representation. Don't think there are two ropes are there. I'm making clear. Please, you have to have some sort of common sense. There are no two ropes. There is only one rope. This is antinode. What is the distance between node and antinode? Lambda by 4. Distance between adjacent nodes, lambda by 2. Okay, fine. These are called as nodes. Node. How many nodes, how many antinodes? That depends upon the condition that we'll see later on. Just have a look on this. Let me have a water. Okay, I'll go back to the diagram. So when the string vibrates at higher frequency, we see the string in the form of a loop. So I'll write the condition. Some of you will think that two strings are there. Okay, two ropes. If they undergo superficial, get a standing wave. Not two ropes, two waves, two traveling waves. When string vibrates at a higher frequency, we visualize loops. This one. Visualize the string as loops. Or we visualize loops. We notice a loops are formed. There's a one diagrammatic form or a graphical form of showing standing wave. Not two strings are there. Okay, let's summarize all the points one by one. Because this is something very important, the data. Lambda by 2, I'll write it on top. Anybody having doubt, please do clarify. Then I'll summarize the points. I'll write down so that'll be easy for you. If you have any doubt, you can clarify once. It's very good. If you have any doubt, you can clarify. Okay, no, I'll summarize things then. I hope all of you understood. Okay, then it's good. Then let me, what all we discussed, no, let me put in the point first so that it'll be easy for you to once again come and think on that, on this. Huh? Now, when do I get a standing wave? Standing wave means SW here. Standing waves. When two traveling waves of same speed and frequency moving opposite to each other and undergo superposition, a standing wave is formed. Then the amplitude of, I'll write in short, standing wave. The amplitude of standing wave is twice of traveling wave. Yeah, let me write in the bracket, because every time writing standing wave of same speed. Standing wave means SW. So what is the amplitude of standing wave? Will be twice of the traveling wave. Next again. The distance between, for first regarding nodes, no? Nodes are points which are at rest at all times. At all times. Next, what about antinodes? Points which will have amplitude equal to that of standing wave. Next again. Distance between adjacent nodes and adjacent antinodes is lambda by 2. Next again, distance between adjacent node and antinode. Antinode is lambda by 4. So this will help us to locate where they will be. Distance between adjacent nodes and antinodes will be lambda by 2. Distance between adjacent nodes and antinodes, node you write it only, singular. And it will be lambda by 4. Next again. Who will possess maximum, what about antinode? It can possess maximum kinetic energy, that one. So now kinetic energy at antinode varies harmonically with time, and potential energy will be 0. Potential energy will be 0 at all times. What about this one? Kinetic energy, I think I'll write it kinetic. Potential G at node varies harmonically with time, and kinetic energy will be zero at all times. These are points, the points other than all points executing, will write all points excluding excluding node will execute SHM. Okay, these are very important. So you look at the books, no, you would have plenty of questions, theoretical questions, all they are based on this data. Just right. For and these things, how to remember this point? No, don't memorize. Remember that sequence of diagram. Through the diagram, I'm able to write all these things. Getting all of you? So for exam point of view, the diagram helps you a lot, not these points. These points only are asked in exam, but how do you can remember these points? Through the diagram. This is the thing. All points excluding node will execute SHM next year. Again, points on either side of node will always be moving opposite to each other. Next again. Points on either side of antinode will always be moving in same direction. Can you say anything about the what is the phase difference between these points? Let me ask you a very simplified way. What is the phase difference between these points? Zero. What is the phase difference between these 2 points? Pi radian. So you look at the standing wave, we do have only 2 phases now. Either the phase difference between particles will be 0 or pi radian. Am I right? You don't get any other value. The phase difference between points on a string where standing wave setup will be either 0 or pi. That's all over. So these points will have pi radian. These points will have 0 phase difference. That's all. You don't get any other value. Huh? Not like traveling where you get plenty of values. No, there are only 2 unique values are there. Specific values are there, 0 and pi radian. So that is what I'm going to stress here now. The phase difference of points on either side of node, points located on either side of the node. The side of node will be equal to pi. Similarly, the phase difference located on either side of antinode will be 0. So we do have only 2 phase. Either the phase difference between particles will be 0 or pi. Am I right? We don't get any intermediate value. This is very important. Huh? How do you can say? The diagram only says no. We have that arrows, everything I shown. Once again, I'll stress this point. You look at these 2 arrows. You look at these points, how they are moving. You look at the total diagram, they're moving opposite. Now they're moving opposite. Now they're moving opposite. Ah, sir, this is moving down, this moving up. Okay, you come here. Now this point is moving up, this is moving down. At any instant of time, you look at these 2 points on either side of node, they'll be moving opposite to each other. On either side of antinode, they must move in same direction. Got the idea? This one, that's what I'm trying to stress here. Next again. All points will have same time period and all points will execute SHM with the same time period. Will execute SHM, will write it. Huh? All points will execute SHM with the same time period, but with different amplitudes. Okay, agree this. So this is the all points will execute SHM with the same time period, execute SHM with the same time, but with different amplitude. How to calculate amplitude of any point on a rope? I have this formula. You can use this formula. The negative sign, if you want to carry on, no problem. I want the amplitude of point at x equal to 0. It will be 0. X equal to lambda by 4. 2a. X equal to lambda by 8. Root 2a. So like that, the amplitude of different points on a rope, how do we can find out? This particular thing. How to calculate the speed also? The maximum speed of any point. The maximum speed is given by minus 2a omega, or say 2a omega sine kx. Maximum speed of different points. Again, among all who will have maximum speed antinode, different points will have different maximum speed. Means what will happen to speed of this point? Speed of this point. Let me start from here. So it was a test. As it starts moving, speed will increase. When it arrives at mean, it will have maximum speed. How to calculate that maximum speed? We have a formula. Then again, as it starts moving down, speed will decrease. Come to rest. Then again it will, like that, a point on a rope will be executing SHM. When it executes SHM, means its speed should vary with the time. When it is at mean position, a respective point will have maximum speed. That maximum speed of any point is given by this form, not of only antinode, maximum speed of any point. I think we'll make it separate point for this. They will ask you this also, you have to be careful. Can we accommodate everything? Oh, fully filled up. We'll write it here. The maximum speed attained by any point when it arrives at its respective mean position is given by this particular formula. So substitute all the value of x. So you can easily find out the speed of any point. Okay, now we have enough of mathematics. I think the chapter is over. You should say, thank you, sir, very much. Start another topic. Because all the information is we have. So let's do one thing. Sir, I want speed of a certain point. I don't know anything. So I want the speed of a certain point on a string at x equal to lambda by 8 at certain instant of time. Okay, directly substitute x equal to lambda by 8 and put that time. So with this formula, what you can calculate? Speed of any point on a string at any time t. Acceleration of any point on a string at any time t. Acceleration of any displacement of any point at any time t. Like this, now what we have enough information, mathematics here. Okay, no, this is about the standing. Sir, now you can ask questions, sir. Why is still the name standing? Why not they were sitting? Sitting. So here, the energy, which is the net flow of energy through any point, will be zero. How much of energy flows in one cycle? Suppose a 10 joules per second is flowing. 10 joules per second will flow here. The net flow of energy through any point on a rope will be zero. That's why it's called a standing wave. And the energy which is present in this region is confined there only. It will not propagate. How much of energy is present between adjacent nodes now will be there only. Now, in what form this energy is available? Potential energy. The same energy is available now, potential plus kinetic. Now, the same energy is available only kinetic. Now, what potential it was here? The same energy in the form of kinetic. So it is not propagating, you see. The net flow of energy will be zero. How much of power flows due to incident wave, that much of power will flow through due to reflected rays. The net flow of energy per second through any point on a rope will be zero. So therefore, what we can say here now, the net flow of energy will be zero, we can say. So therefore, the energy is made to stand in a given region. That's why the standing wave. Means the overall energy between the one loop, how much of energy in the one loop, no, it will remain there only. Okay, got this a good example. This having kinetic energy. Now the same kinetic energy is available as potential energy here. So the energy confined between adjacent nodes will be there only. Also energy between in one loop will be confined to that given loop only. It will not be given to other loop. So what we can see here, one more thing, the net flow of energy to any point in one cycle is zero. So there is a no net flow of energy. That's why traveling wave, there was a flow of energy. In standing wave, there is no flow of energy. Okay, this is what the theoretical is telling. Okay, let's get into the discussion, which we are very much interested. This is about the standing wave idea. So let me directly drag you to the normal modes. Here is what our topic begins now. That is about the theoretical. This is what the application part. Normal mode.